Okay, so now we're ready to listen to the next talk. It's a lightning talk from our uh, soulmate partner Hasura. And please welcome Tanmai Gopal. I hope I pronounced that correctly. Uh, and give him a round of applause. Yep.
Thank you. Thank you so much, Ollie. Thank you, folks, for having me. I hope you all can hear me fine and see the screen fine. I am going to do a small introduction to Hasura. We're super happy to be here to help kind of support this conference and get ourselves in front of you. My intent here is to just kind of give you an introduction to Hasura, the company, the product, and the team a little bit, and of course the fact that we're hiring. And so just kind of wanted to go over the technology and the product and give you a sense of that. And of course, would encourage you to check out the product and if you're interested in a role, to definitely check out hasura.io/careers and apply there. So it's going to be a super short talk. I might not even take the full 15 minutes of my time, but I shall launch into a quick introduction. So I'm Tanmai. I'm one of the founders at Hasura. I'm the CEO there. Hasura is what we call a GraphQL engine, which means that what it does is it basically provides users an instant GraphQL API on top of their new or existing data sources. And so the idea is that if you have, for example, a database that's kind of lying around, or it's a new application that you're looking at building, or you have an ERP, or you have SaaS services like Stripe or Salesforce or something like that, what Hasura can do is it connects to those data sources. It introspects their metadata catalog, their catalog tables, or their catalog information. It extracts that out and then provides a metadata kind of authoring workflow to our users to kind of go in either via UI or as a configuration file in YAML or JSON to configure the relationships between these data sources and to set up security rules at each of these at the model level. And then as soon as Hasura takes that configuration, it becomes a GraphQL server. So it becomes that kind of critical path service that is now serving your GraphQL API. Hasura runs as a Docker container in your own infrastructure, and we recently launched the cloud version of Hasura as well. Hasura is open source and Apache licensed. You can check it out on GitHub, and then of course we have an enterprise version and a cloud version, which I'll talk about in a bit. We've to kind of go back a little bit and tell you a little bit of the story of how we got here, which is always interesting because I think it was very counterintuitive for a lot of folks that we decided to build a startup with Hasura in the web space, and it was an interesting time because the Hasura work itself came out from work that we did, work that I did in a consulting firm that I used to run before I started Hasura. And at the time, we started building a bunch of services, and well, because we kind of wanted to get our hands dirty with Haskell in production, we started writing everything in Haskell. And we built like an API gateway, we built CI/CD tooling, we built a Kubernetes operator, which basically which spins up in your Kubernetes environment and then sets infrastructure up. We built a lot of those things, and then one of these things that we built was also the data access layer that you see now, called Hasura GraphQL engine. And so we built a bunch of these things, and what we realized was that for a lot of the pieces that we built, Haskell was not necessarily the right choice. And we ended up abandoning Haskell for a bunch of those projects. But for our project that we had on the data access layer, it turns out that Haskell was a really good fit because of the nature of the product that I'll get into a little bit. But what it kind of allowed us to do was it allowed us to build a solid product and start shipping something that was stable, and then iterate through it extremely rapidly with a really tiny team, and then keep kind of delivering new features on top of that. Over the last 2 years since we launched Hasura, it's become fairly popular in the open source community with developers with the GraphQL ecosystem. Hasura users need not know anything about Haskell. right? Hasura presents itself as a service. And so over the last 2 years, it's gotten very popular with the GraphQL community and folks kind of using it for new or existing applications. And over the last year or so, about 1 year into launch, we've started seeing a lot of traction with enterprise as well. And that's been great because organically we've seen Hasura getting used in Fortune 10, 100, 500 companies for fairly mission critical loads. We've had a bunch of folks replatform their APIs to Hasura for mission critical tier 1 applications, and that's been amazing. And that's kind of been the foundation for us to say, well, there's a company to be built here, there's a product to be built here on top of Hasura. And over the last 2 years, we've raised a significant amount of VC funding as well, which is good to keep the lights on. But we've also started monetizing our enterprise user base, and with the cloud version that we have, we'll start monetizing the non-enterprise user base as well. Those kind of that revenue traction looks very good. So in that kind of sense, that's kind of been the journey of everything from kind of picking up Haskell for using Hasura to starting Hasura the company. The open source so the open source product itself is essentially it presents itself as a GraphQL server, and what it does is it's kind of a compiler disguised as a web server, right? That's kind of what the open source product is. So think of it like the analogy that I like to use to describe it is it's kind of like the front part of a database, right? Like a database has a metadata catalog, and then the database uses that metadata catalog to process an incoming SQL query, and then it processes that and then maybe hits storage and extracts data from storage. Hasura does something similar. It's like the front part of a database which takes an incoming GraphQL query and then uses its own metadata and then compiles that, or more accurately, transpiles that into SQL queries that are now going to go hit the database, or maybe query systems like REST APIs or query systems like other GraphQL APIs. And so it kind of creates that execution plan, optimizes that, adds security rules, and then hits other backend other kind of backend databases instead of hitting storage. This is kind of why Haskell has been a great fit, and it's because for two of the portions that two of the biggest components of what Hasura does, one part of it with being the compiler, which is a significant amount of AST manipulation, and one part of Hasura, which is there's a fair amount of dealing with concurrent constructs as well, especially because GraphQL has support for something called subscriptions, which allows you to deliver events to subscribed clients, right? So over WebSockets, you can push data changes or data events back to the client. So for both of those reasons, I think Haskell has been an amazing fit for us. To give you a sense, we've shipped over 45 versions over the last 2 years of the product without, I would say, without almost breaking a single API, right? I mean, sure, there have been a few tiny breaking changes here and there, but overall, we've not broken a single API, and we maintain a release cadence of somewhere between every 4 to 8 weeks. And that speed has been incredible, considering that this is infrastructure software, right? This is something that's running in the critical path, where if something goes wrong, things can go wrong badly, especially for us as a company. So Haskell has been tremendously kind of helpful with doing that, of course. We're also the fastest GraphQL engine, or the fastest GraphQL server. We're the best in class in our domain, and we intend to remain here. This is increasingly becoming troublesome, as of course you folks would know better than I do, in running Haskell in production, especially as we've been kind of iterating rapidly. There have been places where we've had space leaks that have been very hard to trace, that have been very hard to figure out. And we're working closely with the community, and we're working closely with a few people in the community to help kind of enhance tooling here, and to build tooling that will help us understand why there's fragmentation, or where that heap fragmentation is coming from, for example, right? And so there's a bunch of things to do there, but so far we are and we remain the most efficient and the fastest GraphQL service compared to other services in the domain. We're about 5x to 100x faster. I kid you not. the number 100x sounds ridiculous, but given the nature of how we process incoming GraphQL queries, that works. It's also been great for us to make sure that because we enforce authorization. So that means that what Hasura is essentially it's like a security engine for your data, right? What Hasura contains rules that describe security properties of your model. So for example, if an app is connecting to Hasura, a mobile app connects to Hasura and makes a GraphQL query and makes an API call, right, and says, hey, fetch the profile data, right? So it says, get/user or query user ID and name. I haven't talked about GraphQL yet, but just think of it as a REST thing, as a REST service. And so you have an app that kind of makes a request to fetch profile data from some data source. Now, what Hasura does is it takes that incoming query, it converts that into select ID, name from user, and then it adds an authorization rule depending on your metadata. So it'll convert it to select ID, name from user table or from profile table where ID equal to cookie.user ID. So that where clause, right? That where clause represents it's kind of a declarative security rule, right? And these declarative security rules are kind of passed into Hasura's metadata system. So Hasura basically is basically a replacement for that application level authorization that you would have built yourself. If you were kind of building this data access service, you would have built your own API service that would have had all of these authorization rules that would have talked to the database, right? So instead of you doing that, Hasura is automating that. So Hasura enforces authorization and captures security. And this is a tremendous thing for our users because you have thousands of tables, you have billions of records. You're just able to kind of point Hasura to that and set up something within a day that would have maybe taken you weeks to build by hand. And what you get out of it as a user of Hasura is that you get better security. And I think that's been being able to enforce that and us being confident about shipping this product where we can control authorization it's been important, and it's been nice that being correct and translating whatever idea we have in our mind to code, that piece does become very important. So kind of for all of these reasons, what Haskell has really helped us do is make sure that we've been able to, as a startup, ship extremely quickly, compete with developers building something in-house, and of course compete with making sure that people in enterprise and people in SMBs or people in startups can use Hasura in production. The enterprise version of the product that we have is basically uses the open source product as a library and builds features on top of it. And then the cloud version of the product, which is very exciting, is kind of a re-engineered version of the open source product, but where we've made it multi-tenant. So the idea is that usually when you have, for example, open source software, one of the standard things to do to kind of build a business on top of this is to host the open source software and provide a hosted offering, which is great. But the problem often is that when you provide a hosted offering, it becomes a cost plus model. So then what you're essentially doing is that as a business, we have to compete with Hasura running on something that's a Hasura that we run versus our users running Hasura themselves on AWS, right, or on whatever cloud vendor. And for us, since we are also going to be using these cloud vendors, right, because we don't own our own data centers yet. Because we don't own our data centers yet, we have to kind of run these systems, or we have to run Hasura on AWS ourselves as well, right? Which means that we have to pay that same amount of cost that our users would have been paying to AWS anyway, right? And so what we did was we kind of re-engineered Hasura open source to, instead of kind of just running one instance of the process per user, we kind of made that we made a single process multi-tenant so that we can have thousands of users or thousands of Hasura users, right, running on one instance of Hasura. And that's been amazing because we've been able to exploit multi-tenancy basically, right? The same thing that other vendors do for you, which is when they exploit that kind of spare capacity and the fact that not everybody's running at 100% all the time. And that's been amazing for us to kind of create that cloud offering. And overall, the way we think about Hasura Cloud is that it's kind of like a CDN, but for your data, right? It's kind of like a Cloudflare or an Akamai that is fronting, these CDNs are fronting static data. We're kind of a CDN that's fronting dynamic data. That's data inside. That's fronting operational data sources, right? So it's a different kind of challenge. It's a very interesting challenge, but that's kind of the way we see the product, right? So it's this infrastructure that is worldwide, that is globally distributing data, that is using that is then connecting to data sources that belong to our users, right? So it connects to your database, it connects to your ERP, it connects to your SaaS service, and then provides data access. It provides distribution, security, governance as a service, right? And of course, as you can imagine, running this cloud offering on Haskell is going to be an interesting choice. Uh, yeah, it is going to be a very interesting thing because of the amount of instrumentation and tooling and debugging and things that we'll have to do to keep the system running and to keep the system healthy. It's going to be very interesting, and I look forward to contributing as much as contributing a lot of tooling that comes out of this to the ecosystem as well, and kind of investing in that. And so that's something that's going to be vital for us. I'm going to quickly talk a little bit about the engineering and the team before I wrap up. And so Hasura we are a small team. We're about 40 people. We're spread all over the world. HQ is in San Francisco, and there's a significant part of our team in Bangalore, India as well. But about a third of the team is spread all over. So we're in Australia, Vietnam, Europe. So fairly distributed. We've been distributed for about slightly over a year, and all of the nightmare things and good things that come with being distributed are things that we partake of, I guess. And kind of the engineering ethic is that we're extremely high velocity, right? I've used a lot of adjectives here, but there you go. Extremely high velocity. So we ship really, really fast. We have to make sure that we're adding value to our users as quickly as possible, but at the same time as an infrastructure product, right? Not as something that gets updated once every 6 months, right? It's as kind of SaaS as you can get, and then of course being the fastest or the highest performing entity in its class. So as an API service, there is not an API service today that does what Hasura does and that rivals its performance, and there never should be. And so that's kind of the way that's kind of the way we think about engineering, and the requirements that we have from our engineering team. From the set of Haskell engineers that we have the pleasure of working with some of the best Haskellers in the world, and it's been amazing. And we've been able to deeply focus on a few problems. We've been able to make gigantic refactors while still shipping, and that's been amazing. And the kind of people that we attract to the team are. I did not imagine using this adjective a few years ago. If somebody would have said, "What kind of people do you like working with?" and if I said nice people, I would have shot myself. But that's a good adjective now in hindsight. The team is full of nice people, and we like nice people. People who are basically they're good people, good values, progressive values. They're kind people, deal with humans as they are wherever they are from, whatever work they do, and people who are empathetic not just to kind of the end user but also to each other. And of course, kind of one of the things that's been most important for us is a product thinking mindset, because one of the things that's often that's kind of important with the kind of work that we do is that the solving the domain problem can become a bit of a rabbit hole. And so as an engineering team, you can kind of enter this Haskell rabbit hole of saying that we want the perfect model to describe what we want to do, and that ends up taking far too long. And so kind of being able to make that trade-off and say that even for a technical product to say that this is how perfect Haskell we want to be, versus getting the job done. And I think dealing with that trade-off has also resulted in interesting things over the last few years. So that's pretty much it. Please do check out hasura.io/jobs or hasura.io/careers. They will redirect you either way. And we're hiring engineers, we're hiring senior engineers and tech leads. Please feel free to reach out to me on Twitter. I'm Tanmai Go on Twitter, and feel free to reach out to me if you have any questions about Hasura at all. But most of it is you should see on GitHub itself. And that's pretty much it from my side. Thank you so much for having us, and I hope you have a fun rest of the day.